class of design and analysis of experiments. I'm going to briefly introduce what we're going to discuss today. As you remember from the previous class, we were talking about the general concepts of this new subject that you are taking in your engineering program. After you have read something with more detail about it, today we're going to actually introduce the topic. What is the design and analysis of experiments? Before I explain my outline, that as you can notice, it's quite concrete, I would like that you ask the following question. Today we're going to discuss some general concepts that I need you to have very clear in order to understand the following topics. And let's just consider this. I guess all of you have tried some of this. Oh. And let's imagine the following. Imagine your mother, even yourself, boyfriend, girlfriend, whoever, who is preparing these hotcakes, alright? So, how do you know, or how do they know, how many ingredients they should have, the amounts, even the time to bake them or to cook them? What do you think about it? Please feel free to jump in any moment with any question. But right now I want you to answer that. Please tell me, how do you know that? How do they know that? Who can tell me that?
No.
Yes, Juan?
I remember.
By memory?
They've done it before.
They've done it before? Okay. Yeah.
Because they read the recipe?
Exactly. Both are correct, but how does that recipe originally was created? Who created it? Well, someone who maybe after several trial and error, they discovered this best recipe to have like the best hotcake in that moment, right? And then someone put that on paper, and that's it. We have the recipe for a good hotcake. Again, we are assuming that someone else did that discovery, now we're using it, we're replicating that experiment, let's call it like that. And I want you to think of that as a general process to create knowledge. Now, the answer to how do we know what we know is kind of answered by that thing that we are going to discuss today, the scientific method. That thing is basic for us as engineers, since, as you know, what you will do for a living is what, as engineering, as any engineering student, what you will do for a living? Please tell me, in general terms, very general terms.
Resolve problems.
Exactly. You as an industrial engineering, civil engineering, IT engineering program student, what you will do for a living is solve problems, right? But we need a procedure that will be reliable, that will follow steps. Maybe sometimes you will apply each one of them with much detail, maybe some of them with not that much detail. But again, we need this procedure, the scientific method, to prove our theories, to create knowledge. I guess you all should remember from a basic statistics course or science course maybe at high school, the general steps of this procedure. It is basic for us in the design and analysis of experiments to understand it fully. I want you to help me answering the following question. Please open your app that I told you to, in your iPhone, in your iPad, in your computer. Go to the app that I gave you a while ago, and I want you to answer the following question. Please tell me what you think about how related is a scientific method with engineering disciplines. Please answer that. I just want to know your opinion about it so that we can continue discussing this topic. So go inside the question, click, and then select the answer that you think would be the most adequate one. vote. It's a very crowded classroom. So, all of you have said that the scientific method is very, very highly related to the engineering disciplines. Yeah, you're right. Why? Because, again, as engineers, what we do for a living is solving problems. But we need to do that with a procedure that has been proven to work, and again, that is like scientific methodology. So today, we'll go back to our slides, and I want you to think of the following. The objective for today, it's very clear. I want you to have a good idea of what the design and analysis of experiment is. How do we create knowledge? I already told you. By following this methodology, by answering to an initial question, making analysis using statistical techniques, using previous research, etc. That's how we create knowledge, through the scientific methodology. We're going to see that with more detail. And then I want you to give me your own definition about the design and analysis of experiments. Again, why all of you, even though are from very different disciplines of engineering, take this course? Again, and I will reiterate, because this is an essential tool for you to create solutions to problems. Good. Any questions so far?
No.
What's DOE?
What, sorry?
DOE.
Okay, good question. Actually, it's explained over here. But design and analysis of experiments. You will find in most books only design of experiments. We're going to use that as a reference, all right? Design and analysis of experiments, or design of experiments. Good. So, how do we know what we know? Let's find something about the scientific method. Right? We're going to be using a website from the Museum of Science at San Francisco, California, Exploratorium. Let's see this. Alright, so please tell me, when you want to create knowledge, a small or big theory, to a large or a small problem, what's the first step? What do you do first? As a scientific, as an engineer, what do you do first? What should we do first when you want to create the solution to a problem? What do we do?
Define.
Exactly. First, we have to define what the problem is. I want to create the best hot cake ever. That's my problem. That's a problem. So, everything will start with a general question. How do we create the best hot cake? What's the best recipe for a great hot cake? That would be the question. And that will trigger this process, this methodology. And then what we will do, of course, is to try to find the answer to that. How do we answer that? How can I answer that? Well, as you can imagine, it is